Hey everybody, Mrs. Kroll here. This video is on section 2.5 and 2.6, which is verifying segment and angle relationships. I'm starting off with our essential question, which you should get down into your notes. How can you prove a mathematical statement using algebra explanations? This is not going to be right. Let's try this again. Okay, so it's going to be how can we prove mathematical statements using geometric reasoning. All right, and the reason we're going to change that, this is an E, sorry. All right, the reason we're going to change it is because we're not going to give all of our algebraic explanations. We're going to end up using all of our geometric reasoning, and we're going to talk about some of those reasons here in a second. So as we do the mathematical problem, we have to make sure to prove it. All right, we need to write out the geometric reasoning is what we're going to be doing. So that's why prove is underlined, is because every time you're going to write out what did you actually do. So pause the video at any time if you need to take some extra time to copy these down. These are all the theorems that we need to have from chapter 2. Some of them we've already talked about and written down, but this is what we're going to use as our geometric reasoning. This is going to be what we do and what we explain every single time. So the first thing that we want to do is get all of these down into your notes. So like I said, pause the video at any time if you can't keep up writing them as I am going through them. The other thing that we're going to do is save some room because we are going to draw a picture for each one. Okay, so I'm going to get out some different colors here so that I can color code them as well. Sometimes I like that a little bit better too. So first thing, vertical angles are congruent. So if we're going to draw vertical angles are going to be created by two intersecting lines. And then vertical angles are the ones opposite each other. So I'm going to label this one angle 1. And if I go clockwise around it, this one would be 2, 3. And I'm color coding because those are my vertical angles. So vertical angles are always going to be the same. So they're the ones opposite each other. Okay. And they are congruent, which means they have equal measures. So I'm going to write out angle 1 is congruent to angle 3. And angle 2 is congruent to angle 4. Then the next one, perpendicular lines intersect to form 4 right angles. So again, perpendicular lines, we draw them, all right, out. And then we know perpendicular means that it's going to create 90-degree angles. So when we draw perpendicular lines that extend on forever, all of these are going to be right angles so that we have 4 of them. Okay. Remember, right angles are 90 degrees. So if you want to write that after here to remember, you can do that. And then we use this little box to represent 90 degrees. And so then there's 4 of those little boxes because we have 4 right angles. The other thing that I always like is to kind of remind yourself, perpendicular, we can shorthand that with an upside down capital T. So perpendicular, and I always kind of remember because it kind of looks like the top part of this with the 2 right angles. So perpendicular lines intersect to form 4 right angles. As you're writing out your reasonings, you can always end up using shorthand. So perpendicular is one that you'll see the upside down T a lot. All right, next one, all right angles are congruent. Oh, because we know all right angles have to be 90 degrees. So every time we draw right angles, they're always going to be congruent to one another. So if I'm going to draw this one, I'm going to draw 2 right angles. And I'm going to label them with that measurement so that I know that they have to be congruent to each other, because they're always going to end up being 90. And that's why I have the boxes there. All right, next one. Linear pairs are always supplementary to each other. Remember, supplementary we talked about is going to always be equal to 180 degrees. And why is that? Oh, because a linear pair is makes a straight line with those two angles. Those opposite rays here, right, or non-adjacent rays are always going to be opposite each other, making them equal to 180 degrees. So to write that out in words, I'm going to label this one angle 1 and this one angle 2. So the measure of angle 1 plus the measure of angle 2 equals 180 degrees. Okay, 5 and 6 are going to be very similar. Angles supplementary, I'm going to make myself a little note, 180 degrees, to the same angle are always going to be congruent. So let's talk about what that means. So if I have a 30-degree angle right here, and I'm going to label this one as angle A. Okay. Now I want to draw its supplement. Well, I know it has to equal 180 degrees, so if this is 30, oh, well then the other angle, to get it to equal 180, has to be 150. Because 150 plus 30 is going to equal 180. And I'm going to label this one angle B. So that gives me the first part here, angles supplementary. These two angles are supplementary to each other. So I'm looking at that. Now I want to have another angle that's supplementary to the same angle. So what does that want me to do? Well, I'm going to cover up angle A. And I want to draw an angle that is supplementary to B. I want it to be supplementary to B. Oh, well, supplementary is still going to stay 180. So to draw one that's supplementary to B is going to have to be 30 degrees. So down here below, I'm going to draw a 30-degree angle. And so that I have a different name for it, I'm going to name it angle C. Now, what do you know about angle A and angle C? Oh, they're both supplementary to B, and since they're supplementary to the same angle, they are going to be congruent to one another, which we can see they're both equal to each other. Angle A and angle C are congruent. They are both 30 degrees. Now, 6 is going to be the same exact idea, except complementary is 90. So I'm going to draw angle A at 20 degrees. And its complement then would be angle B. Complement means it has to be equal to 90. So to be complementary to this 20, B is going to have to be 70 degrees, because 70 plus 20 is going to be 90. And then I'm going to cover up A, and I want to draw another angle that is complementary to this same angle. So complementary, 70 plus what's going to be 90. And so that angle is 20 degrees. Label C. Oh, so since they're both complementary to the same angle, angle A is congruent to angle C. All right, so like I said, if you need to copy down any of those theorems, pause your video and you can go back and rewrite them all down. If you have any questions, please ask. All right, so we're going to do a couple practice problems then to go along with this. We're going to have our work and our reason for each one. So the first one is saying that angle 2 is 80 degrees. Find the rest of the angles. So for my answer, I'm going to have the measure of angle 1 equals something. The measure of angle 2 equals 80. I know that for sure. The measure of angle 3 equals something. And the measure of angle 4 equals something. Now, I know that this is 80 right away because that's given to us. That was given at the very beginning. But I need to list out my geometric reasons for all the other ones. Well, the first thing that I'm going to look at is angle 2 is across from angle 4. And so as I look back at those reasons from the last page, oh, those are going to be vertical angles. So angle 4 will also be 80 degrees. And my reason for that is because vertical angles are congruent. Then I can look, okay, well, what else do I know? Well, angles 1 and 2, if I put my hand down here, end up making a straight line. They're going to be a linear pair. So I know I can take, and I'm just going to kind of do my work over here, 180 minus 80 to equal 100. And why do I know that? Because linear pair is supplementary. Okay. Every time you have a linear pair of angles, oops, and I'm kind of off the page there, they're always going to be supplementary. And now you could really do two different ways. You could say, oh, well, 1 and 3 are vertical angles, so they need to end up being the same. Or you can say 2 and 3, because 2 is our given, they create a linear pair. And since they create the linear pair, we can subtract from 180. And 80 subtracted from 180 is going to be 100. Linear pair, supplementary. So each time we do these problems, your reasons, you're always going to list them out. All right, we want to know all of those geometric reasons. And then just double check to make sure that you've answered the question completely. It says find all the rest of the angles. So 1, 3, and 4, we should have measurements for all of those. All right, here's number 2. So in this case, it gave me 3. The measure of angle 3 is 7x minus 10. And the measure of angle 4 is going to be 5x minus 2. So I look at these two angles, 3 and 4. And again, I can see that they make and create a straight line. So I know that these are going to be a linear pair of angles, the two of them together. So 7x minus 10 plus 5x minus 2 equals 180. And what's my reason for that is because linear pair is always supplementary. Now, this one we're just going to end up solving. So we can solve for x because the question asks us to find the value of x and then the measure of angle 2. So combine your like terms, so 12x minus 12 equals 180. So 12x, and then I can add over my 12, 192. 192 divided by 12 gives me x is 16. Now we also need to find the measure of angle 2. And you look at it and you're like, well, there is no number there. Well, I know that angle 2 is congruent to angle 4 because vertical angles are congruent. So the value of x can get plugged right into angle 4, and that's going to be the same as angle 2. So 5 times 16 minus 2. The measure of angle 2 then is going to be 78 degrees. Okay. Oops. Hold on one second. My light just turned off. There we go. Make sure you can see it all the way. Okay, so now here's the next one. Now this one is on segments, not off of the angles anymore. So when I look at it as a segment, oh, well, this is going to be my midpoint. And since it's my midpoint, it's going to be exactly in the middle. Okay. I know that this half is going to equal this half. So I know that 7y plus 10 equals 12y minus 5. And my reason is the midpoint creates two congruent segments. And you can shorthand, if you watch, I'm going to always shorthand midpoint to mid and then point PT. You can use shorthand, that's okay. Just make sure that it's all legible when you're writing out your reasons. Same thing with congruent. I'm always going to use the shorthand for congruent, which is going to be the mathematical symbol. All right, so now we're going to find y, and then we're also going to find AB. So the first thing I'm going to do is I'm going to add the 5 over onto this side to get 15, and then I'm going to subtract the 7y over here to get 5y. Solving for y, I'm going to divide both sides by 5, so y is equal to 3. And now we got to find AB, so we're just going to take 3 and we're going to plug it in for the entire thing. So it's going to be 7 times 3 plus 10 plus 12 times 3 minus 5. And so AB is 62. All right, we're going to do one last one together. Actually, that's going to be it. All right, we're skipping this one. All right, so let us know if you have any questions, and we will be happy to help you as you practice the rest of them. If you need to go back and watch the video at all, you can go back and watch the video and kind of go back through how to do each of the problems as you go through your practice examples.